Okay, so we're in the P2 books on page 28. Let's work 1A. These are absolute value equations or inequalities. Equations, how do I know? It's got an equals. So the first thing we do to solve this is drop the bars. X equals 3. The next time we drop the bars, but we make the 5 negative. So x can also equal -7. You should be able to check them. C, 2x minus 3 is equal to 3. So we've got 2x minus 3 equals 3. 2x minus 3 equals -3. So that's 2x equals 6, x equals 3. 2x equals 0, x equals 0. Any questions so far? Alright, E. Now these were the ones that we learned yesterday. How do we approach solving these? Square both sides. And you better get a trinomial. Do not square this by just squaring each term. It is not x squared plus 1 or 4x squared plus 9. When you square something, you multiply it by itself. So I get x squared plus 2x plus 1 equals 4x squared minus 12x. It's confusing me looking like a 2 plus 9. So you're going to have a quadratic. So I've got -3x squared plus 14x minus 8 equals 0. What can you easily do? Polysolve. And you should have gotten 2/3 and 4. Is that correct?
I didn't do that, but I somehow got the answer. I did the regular. I mean, it makes sense.
This is E.
I don't know what I'm doing.
No,
Did you do the drop the bar thing?
she just made them negative and ended up,
I did both. It was a section 2, but I did both of them.
Yeah.
Both of them got the same answer.
yeah.
Okay.
All right, let's look at G. So if we square both sides, I get 4x squared plus 4x plus 1, 9x squared plus 54x plus 81. And we get -2 and -8.
You're just trying on that Just trying on that because they're not negative.
No, it should have come out exactly.
Okay. And then mine were all positive.
That's fine if you moved everything over. You had the same numbers I did. Get your calculator out and just retype it in. I think you just hit a number wrong.
I put plus 81 instead of plus 80.
Oh, plus 81. That's how you got that little bit of a difference. Yeah. All right. Any questions with number 1? Any of those problems with number 1? All right. Let's do the number 2. You had E and G. These are absolute value what? Okay, and so this one works a little bit differently. You have to use what here? The sign chart. So guys, because of what we talked about the other day, with this going to be a quadratic and I want to be able to read the sign, I'm going to move all of these over here. I want to get everything on the left with any inequalities, just to make life a little bit easier to read. One half and negative 3/4. I believe it goes negative, positive, negative. Okay, so looking back at the inequality, I'm looking for the positives or negatives. Negative. So I want this section and I want this section. So x is less than negative 3/4. X is greater than 1/2. All right, are we okay on those? All righty. And 2G. So I'm going to square both sides. I'm getting lazier and lazier. Was this 1 and 3?
Yeah.
Negative, positive, negative. They want the positive section. So it's between 1 and 3. Now, let me give you a quick note of instructions that's really important. What would you consider this value of x? Let me just ask you. Thank you. That's the exact word I was looking for. The greatest value that x can be. And what about this one? The least. Turn to, or at least on page 28, look at number 2. In your P2 books, look at number 2 on page 28. If you had read number 2 on page 28, tell me what you would have thought. Would you have thought all I have to do is that? Okay, it doesn't occur to me, honestly, when I'm working problems, especially less than problems, that one's the greatest value and one's the least value. You know where my brain went? Quadratic, max min. That's what I went to when I first read the instructions. I was like, oh, what? Are they wanting a max and min? But the point I'm making, when you see the instructions say find the greatest and least values of x that satisfy that inequality, all it's asking for is the answer. Oh, I'm so sorry. Under miscellaneous, I'm sorry. So Melanie, Chloe, those of y'all who couldn't read my mind, I'm so sorry. Can't imagine why you can't read my mind by now.
I was thinking
Yeah, I was looking at your book.
So, do you see that problem, the way they word it, could trip you up and you're thinking, I have no idea what they're talking about? Because we're never really taught to look at this as, right, that's the maximum value X can be and the least. It's like we know it, but nobody ever puts it out there in words. So if you see something like that, know that it's only solving for the inequality. All right, so any questions where that one is concerned? Okay, so we need to go backtrack just a little bit to page 13 in the same P2 book. We've got to talk about the factor theorem. All right, so we're going back and kind of picking up, okay, there we go. Y'all take out your phones for 1 minute. Right, 10, 9, 8, 7, 6, 5, 4, 3, 2. All right, let's put it away. Okay, so how do you know that something, in other words, like x minus 2, for example, is a factor of another polynomial, like x squared plus 2x minus 5? How do we know that? It would have a remainder of 0. Okay, factors have no remainder. So this takes us back to in order to find factors, we have to do the possible rational roots. Now, guys, for the sake of time, right now, but I'm going to crack down on y'all come next March and April. If you have an x squared polynomial, if you have a quadratic polynomial, or if you have a cubic polynomial, I'm going to let you use PolySolve on your calculator to find the roots, which will lead us to the factors. Anything above that, you have to do the possible rational roots. Okay, so I'm gonna start off kind of basic. Now, I'm gonna give you this problem. They always call it factorize and they spell it like this. That just means factor. Okay, so everybody get out your calculators and we're gonna do poly-solve for the cubic and I'm gonna show you where we're going to go. So go ahead and do your poly-solve and you should have me 3 different answers, I believe. Did they give you 3 answers or no? Okay. Tell me what they are.
-3, 2, 1, -1.
2 and -1? Okay. So, how many roots or zeros or answers, because x equals all of these, right? So if we're solving for x in this problem, these are my answers. They are not the factors. They are your answers, your roots, or your zeros. People can ask for them. Your x-intercepts. They can be referred to as your x-intercepts. Guys, it's wherever. So it's looking something like this. It's going to come up through -3. It's going to go through -1. And it's going to come up through 2. So these points right here are your x-intercepts, your answers, your roots, your zeros, but they are not your factors. Now, they gave me 3. How many did I expect to have? Did I expect to have 5? Did I expect to have 2? I expected to have 3. Why did I expect to have 3? It's a cube. Now, there will be some times, well, let me stop. I'm getting ahead of myself. Okay, so they gave you the 3 roots or zeros. How would I write this in factored form? Because that was actually what they asked me to do.
X plus 3. X minus 2.
This, everybody, are the factors or the factored form.
I thought when you found possible roots, you would put that over the coefficient.
We do, but in x cubed, we're lucky enough that we have the poly-solve. We're going to do it for an x to the 4th. The poly, now, come next March and April when we're reviewing, I may make y'all list because it depends on when I look at the mark scheme. If they want to see all the possible rational roots, you're going to have to do plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, all over plus or minus 1. And if I look at the mark scheme, because I can't remember those details off the top of my head right now, but if I look at the mark scheme and they have to have that for you to get the points, then you're going to put it down. But right now, I'm saying for anything that's squared or cubed, I really want to spend more time on the rest of this objective, and then we'll come back to that. If it's not a problem, we can just slap them down, but I want to make sure, and you'll know that before you go on the test. Okay, but here's the big difference, is if I asked y'all to put the factored form down, and you left this as your answer, you're going to throw some points away. Because factor form means this. Okay? So what happens when you polysolve and you don't get the number of roots you need? Okay? Write this one down. I'm going to make sure it works first. Wait just a second before you write it down. Okay, that one's fine. Okay, so what happens when polysolve doesn't give you all the roots? Okay, so take out your polysolve and do it for x cubed minus 1. So, did you get any roots? X equals 1. What were the other two? Yeah, weird. Sometimes weird are referred to as imaginary. So you saw some long decimal, plus another I, if you kept looking at it. Okay? So here's what happens. Trying to get this to erase. This is actually, I showed you a cubic a minute ago. So this is what happens. It comes up through 1, does this business, but never goes back through the x-axis. Okay? So you might have, and I'm going to tell you guys that those a plus bi, the imaginary numbers, always come in pairs of 2. Always. So you'll never, ever, ever, if you have a cube like this, you'll never, ever, ever have 2 reals and 1 imaginary. Never. Imaginaries must come in pairs because they're conjugates. Does anybody know what a conjugate means? If I have 2 plus I, what would be the other imaginary number that would go with that? 2 minus I. They're conjugates of each other, meaning the imaginary number changes signs. Okay, that's not anything that you have to know right now, but that explains what happens is you've got 2 imaginary roots up here. So what are we supposed to do about this? How are we supposed to show this in factored form? Because x minus 1 is not the factored form of that. So you can't just say, okay, it's x minus 1, done, 1 and done. No. So what have we been doing? Well, what we've been doing is this. Honey, we never leave anything in this classroom for very long. Never. It ensures that you know it, come next May. Okay, so I can basically take and divide x minus 1 into x cubed minus 1, and I will get a quadratic that I'm not able to factor. This will be an unfactorable. In other words, it's called a prime factor. Okay? This one is unfactorable. It is prime. Come on. That's right. So let me just go ahead with the ax cubed. Y'all all did good on this quiz. I got to give it back to you. No, because 1 was a root, which makes x minus 1 a factor. Good question. So I don't put any r there. Okay, so I've got my x cubed, so my a is 1. B minus 1. What am I going to set this equal to? My x squares? 0. Easy to get caught off guard, so B is 1. So C minus 1 also equals 0. Now guys, look up here. When you get finished writing, I want you to look up here and I want to explain something that ought to make sense to you. Okay? C minus 1 is 1, so you think, I'm done with my C. And I've crossed this out. Some of you are not crossing this out, and you're going to have an activity today. When you don't cross them out, you're going to miss something. Okay? I'm not saying you have to, but 99 times out of 100, you're going to go, oh, okay. C is 1, I'm done. But check to see if this is right. Negative C equals negative 1. Does that make that true? Yes. So it's a really good check because I was working something last class and I started getting down and I was like, it wasn't working out. And I knew I had done something wrong. So pay attention to that. You can think, oh, I've got my C, I can stop. But continue to look at that. You're going to need that later on today. So actually, the factored form, now everybody look up here. My factored form is I'm going to write this out. Okay? I'm going to write this out with my A's, B's, and C's. Let me write this. I'm going to change this real quick. I'm going to do y equals. That's one factor. We know that because the remainder was 0. What is my A? 1. What is my B? B? 1. What is my C? 1. Now I told you up here that this is prime or unfactorable. Why do I say that it's prime? What does prime mean? We think of prime with numbers, but we don't think of prime with quadratics. 1 in itself. Can you tell me anything that multiplies to get 1 and adds to get 1? But 1 times 1 is 1. But 1 plus 1 is 2. So can I break this down to any further factors? So if there are no other factors but 1 in itself, it is considered prime. Okay? So this is the factored form of x cubed minus 1. So I want y'all to do x cubed minus 8. I want you to factor this or write it in factored form. That's right. When you do your polysolve, whatever x's you get, they are roots, so they lead to factors, which means no remainders. How many here want to retake that last test by show of hands? One. If you want to know what you made on it as on active student, or I can show you later on. Okay. I've got to determine my dates, and we'll probably have to come in here during a couple of EFAs.
With the retake, do you just take both scores and average them? I forget what's on last test, honestly.
Gradient, distance, midpoint, decay, perpendicular bisector, modulus, points of intersection. What did you get from your polysolve as your root? 2? Okay. So, we know what is a factor. X minus 2. So, to find the other factor, and we know this is a factor, so there's no 0. We walk through that whole thing. So I've got ax cubed, bx squared, cx minus 2ax squared minus 2bx minus 2c. So my a is 1. My b minus 2 is 0. I hope y'all put a 0 there. So b is 2. That's a B. C minus 4 equals 0, so C equals 4. So I think I have my C, but let me double check this. Negative 2 times 4 equals negative 8. So I know I've got all the right ones. Are there any questions on doing this process? All right, so my factored form would be x minus 2. My a is 1. My b is 2. My c is 4. And if you try to do the polysolve with the quadratic, it's going to give you imaginary numbers because there's nothing that multiplies to get 4, 1 and 4, 2 and 2, and they don't add to 2. So it's not factorable. This is the factored form. Now, what else could you do to make sure it is? You could, but there's an easier way. Put a number in, check this against that. Okay? All right, any questions on that? So we're going to move on to what happens. So that's kind of what happens if you have an x cubed. Let's do a what happens if you have an x to the 4th. We're going to factor Because we've done all the polysolve we're gonna do. Okay? Now I'm gonna make this really easy on you. You have to get the possible rational roots. So some of y'all wanted to start doing that in a minute, or a minute ago. So with possible rational roots, we list the factors of our constant, 1, over the factors of our lead coefficient, which is also 1. So I have 2 possible rational roots. So how do we determine which one of those is my root or my 0? Store them and check the remainder. All right, so go ahead. Okay, so that means that they're both roots. So they have how many factors that they've already shown me? 2. What are they? X minus 1 and x plus 1. So guess what? If we have 2 factors, we're going to get to do the A, B, C thing how many times? Twice. Because I have to get it down to a quadratic. I have to get it down to a quadratic. They only gave me 2 roots. I'm expecting 4. So what do I know my other 2 roots to be? 0 is an actual root. What do I know about the other 2 roots? They are what? They are imaginary. I have 2 reals and I have 2 imaginaries. So I have to get it down to a quadratic that is not factorable. All right, so let's take this first one. I'm going to set it up and I'm going to do everything like I know to do. Yes, I know, we're tired of it, but gosh almighty, when y'all see these come next March and April, I hope you're like, yes, ones we know how to do. So, I've got, I made a big mistake. What did I do in my talking and not paying attention? I have to have an x cubed here. Yes. So oftentimes my brain and my mouth don't work together. All right, are y'all so sick of these you just want me to go in and work it out? I get it. Alright, so my A is 1. Done with that one. That's supposed to be a cube. So B minus 1 equals 1. So B equals 2. That's right. C minus B. Do I have any squares up here? Alright, big mistake I made working it last period. I put me a -1. It's 0. So be careful. It's not that this stuff is hard, but it's little stuff that like that will mess you up. And if you're not crossing these out, you're also gonna make some mistakes. D minus 2 equals negative 1, so D equals 1. And does that make sense? Now just D equals, no, negative D right here equals negative 1. So we know that that is true. So all of these worked out. So my next factor is my A, my B, my C, and my D. Let me double check myself. Okay. But we're not down to a quadratic yet. So, what do you have in this parentheses? What is this? What is that? It's a cubic. So you can do polysolve and get any roots of that cubic. Y'all, I'm saying too much, I'm sorry. Okay, so the next root is negative 1. So how would I make that a factor? X plus 1. Now, what I'm doing is this now becomes the x cubed is the one that becomes the left side. So what do I want to put here? Ax squared plus bx plus c. Okay, I'll work this one out. I think y'all are pretty adept at doing this, but we'll. So my A is 1. I'm looking at this now. I'm not looking at the quartic. I'm looking at the cubic. So B plus 1 equals 2. B equals 1. C plus 1 equals 2. C equals 1. That's right. So I have this factor, which I already had up here, right? We knew this was a factor. We also know that one is a factor. And now we know that one is a factor. All right, what questions do you have? It's the same stuff we've been doing, but you see how they throw it all together in one big old pot.
So the top one, like that's the answer for the quartic?
That's the answer for the quartic, because look, I have an x times an x times an x squared. So it is the factored form of the quartic that's at the top. So when the quartic can only offer you 4 reals or 2 reals and 2 imaginaries. Can't ever offer you 3 and 1. Okay? Can't offer you 1 and 3. So you know if a quartic only gives you 2 roots, you have to divide, get a cubic, divide again, get a quadratic. You'll have to do it twice. Every time.
And will it like, so, when you were doing it for the cubic, you happened to get, -1 is your root, which was the same.
Which was the same one up there. And to be honest, I probably could have used that one. I just always like to check.
Okay.
And it should still be the same, but I always just like to check. Yeah, they were the same 2 roots at the top. questions do you have about this?
What happens to the imaginary one?
They're right here. They're in this.
You don't see them because they're imaginary.
They're in that unfactorable quadratic. So I guarantee you, if you pulled out polysolve and did 1, 1, and 1, it would give you 2 imaginaries. Okay? All right, other questions? Good. I want you to fully understand this so that you can apply it. I don't want you just, yes, ma'am.
I think you already answered this, but like every time you do it twice, whenever it's like,
If it's a quartic,
yeah.
so if it was a cubic, we want to get it down to an x squared. Okay, we want to get it down to an x squared. Because if we could get it down to an x, then I would have had that show up in my polysolve. Okay, good question. I want y'all to fully understand. Anything else? Okay, we're going to do a little class activity.